So after we covered how real attacks look like, how advanced persistent threats look like, now let's talk about penetration testing. There's two different types of penetration testing. One is the traditional penetration testing, we already know, and one was called the red team operations. For penetration testing, when penetration testing is being conducted, the company that conduct this penetration testing, they make a contract with the other organization, and they tell them that they will do different events, and the blue team, the detection team, the response team, has to not react to this attack. They can see how this attack is being performed step by step, but they don't react to it. They don't stop this attack. They don't respond to this attack. They let the attackers move from one machine to another, or let the penetration testers move from one machine to another and actually test all the systems and test all the vulnerabilities. So they only focus on the prevention type of technologies. They focus on all the security controls, but they don't focus on the human element part. They don't test the blue team, they don't test the SOC team, they don't test the incident response team, how they can detect the attack, how they can react to this attack. And they are also very noisy because they know that there's no team behind to detect their attack. So they can run PowerShell commands that's easily to be detected, or different things, or Mimikatz, or things like that can be easily detected inside the system. Also, penetration testing is not intelligence driven, so it doesn't rely on the techniques that's being used against similar organizations to their client. If they are conducting an attack on a petrol company, they should look at how the other petrol companies have been attacked in the past, and who's targeting them, and what's their exact techniques, so we can do something similar and protect the organization against the attacks that they are more likely to face. That doesn't happen in penetration testing. Penetration testing just focus on testing specific things and send a report at the end. Penetration testing, of course, is needed for compliance, for testing specific new features being released, but as well if it's a full penetration testing operation, it might lead to push the company to focus on less important vulnerabilities to patch. So if they are, let's say, if they focused on the web attacks and focus on different vulnerabilities on the web, but they left the spear phishing attacks, the malware attacks, the different security controls, the detection team, the response team, and they left all of that unchecked and not tested, then a real attack may skip completely the web, and they just target the spear phishing with a customized malware, and he can take over the organization very easily. So the penetration testing may lead the company to focus on fixing vulnerabilities that are not the most critical at the moment. Any company might have so many vulnerabilities already, but they need to prioritize them and focus on the ones that are critical and important right now. And that's what is different from red team operation or real attack simulation, which basically it focuses on testing the company security against type of techniques they might face, as well as they don't only test the security controls, but they test the security team, they test the detection, the response, and so on. So how the adversary simulation works? First, the red team collects all the adversaries that might target this organization. Let's say it's a petrol organization, so they will look at all the different attackers that target petrol companies, that target the country this company is in, that might target their organization, and look at all their tactics, techniques, and procedures. All the things that they do, exactly their behavior, not the exact command, their behavior, and then they simulate that attack. They put a plan to simulate that attack, and then they build the tools that build their tool arsenal. Let's say they want to simulate this malware, so they build a customized malware that does exactly like the malware that they saw by these attackers. Let's say this malware was communicating through HTTP, it looked like this. Of course, they don't take the exact network, exact commands of that malware, but they create a kind of simulation, kind of something that looks very similar. They might use publicly available tools like Metasploit, PowerSploit, Empire, whatever the tools are, or they might develop their own tools so they can bypass defenses much easier, bypass antivirus, and really have a realistic simulation of a real attack. Because most of the attackers, they use their own tools and develop their own tools. Once they have that, once they have the whole plan and the tools, they start executing their attack step by step and report all the weaknesses they have found, and as well communicate with the blue team on what they have missed, the events that they have missed, the alerts that they should have reacted, and how they reacted, and what exactly the mistakes they have done. Communicate with the blue team so they can also build their defenses and learn accordingly, and they can improve the whole company security posture. As we said, they collect the adversaries, they collect all their TTPs on the Metro attack, they put their plan for the attack, and then prepare their tools, whatever they're using, publicly available tools like Metasploit or Empire, which is easy to be detected, or use privately available tools like Cobalt Strike or Simulate. They are paid products that you have to purchase, and they are harder to detect than known tools like Metasploit, but it's still detectable. They can use their own, they can create their own tools, develop their own malware with customized network communication, so they can bypass the antivirus, they can bypass the firewall, the intrusion detection system, and it's way harder to detect. Once they have that, they execute the attack, and well, so this is basically the steps that Red Team operation goes through. You can check the Metro attack APT3 simulation. They have actually a full article on how to simulate an attack called APT3, how they simulated the adversary step by step, from the tools, from the TTPs, from all the techniques that the attacker is using, everything about this attack. Now, we will look at a demo on how to implement just this. So we will take a demo on how to implement the first part, which is the initial access. We have talked about when we looked at the Metro attack, they have the initial access, the execution, the persistence, and so on. We will look at how we can simulate the initial access, and then we will look at how we can simulate the next steps after that. So I will leave you now for the demo and see you back after. So now we will look at one of the most common techniques the attacker use to gain access to their company network, to get their foot inside the company network. And this technique is spear phishing with a malicious document. This malicious document includes an embedded macro in VBA language, Visual Basic for applications, and this code basically downloads and executes the attacker spyware or the attacker malware, and from there he takes control over this workstation. And from this workstation, from this machine, he can move inside the network from one laptop to another, to a third, to a fourth, until he takes over the domain controller. We'll look at how we can replicate that attack. If we are doing pen testing, specifically if we are doing an adversary simulation, we will sooner or later we will simulate this type of attacks. We will create a malicious document that includes a macro, and this macro connects back to us and download something from our website, from our CNC, and download additional malware, and this malware gets executed on the system. And we will do exactly that right now. So let's assume that we are sending to the HR and we are trying to spoof them as we are basically a candidate that's applying for a job, and to see our resume, they need to enable the macro. So we can choose this template right here, blue-gray resume, and you can of course add here that you have to enable macro to see my resume, or here you need to enable macro to see my skills, whatever it is, the way you can push them to click enable macro. And then we won't write the macro. How we can write or embed inside this document a macro, and this macro downloads our malware and gets us to take over the machine. So we can click on view here, and then we click on macros, and macro here we will need to create any macro. We can create it. We can call it test, we can call it whatever. We can delete that one and create a new macro. Let's say we'll call it malware, and then click create. Once we are here, we will see that Microsoft creates for us some code that we can fill here with some, creates like a rubber around our code, so we can write our code up here. We actually don't need to write our code here. And before I go into where we need to write our code, I just need to explain something for you. I know that you might not be a developer, you might have never wrote a single line of code, but today we will make it very light, very simple. And just I want to explain to you that Visual Basic from 90s until now, they used to have they have a specific format on how they write any code that executes when an event happens. We want our code to run every time this document gets opened. So for creating such code, or to create some code that happens on that specific event, we need to choose our document, and it choose the event, the object of the document, of this document, and the event open. So we have a file here called this document. It's under projects, under Microsoft Word objects, and it's inside here. And here inside that file, we can choose our object document. That is this document. This is the object that we want to write code for. We want to write code in some of the events that happens to that document. This can be something else. Let's say in normal Visual Basic code, that could be, let's say, a button. So you want this, when this button gets clicked, something happens. So you go here and you choose button 1, and then you choose, let's say, from here click, and then he will create for you a function looks like that, or a wrapper for your code looks like that. Private subroutine, let's say here for us document, which is our object, and then underscore new, which is the event that we want to write the code for. For a button, for example, it will be button 1 underscore click. For something else, could be image, mouse hover, or a mouse right click, or whatever we want to write the code for. So here we choose the object that we want to write the code for, and then the event, and it looks exactly like that. For our case, we don't want to write an event for document new, we want to write an event for document open. So when this document gets open, we need double click on our resume file, and the file gets open in front of him in Word. We want this our malware to be executed directly after. So we will write code under documents, under this subroutine document underscore open, which means this document object, we want to write a code for its event, the open event. So we'll write the code under this one, so we don't need the previous lines, and we'll keep it here very short. We'll not go into so much coding here, but there's one Visual Basic command called shell, and shell allows you to execute any code as you are actually inside the shell. It's like a direct access to the command prompt, a direct access to the shell, and you can write any command up here. Between brackets, you can write dir, you can write system pause, you can write, let's say, curl to download something, which is mostly in Linux, not in Windows. But inside Windows, we can use one of the most powerful tools or most powerful languages for the operating system, for Windows operating system, which is PowerShell. PowerShell is basically a language that is being used by administrators on Windows, created for administrators, and it gives so much control over the Windows operating system, and gives you so many abilities. And we can basically use it directly from here, PowerShell.exe, and then we can give it any command we want to execute by giving it the parameter -c, and then any code inside of here, and it will be executed. But the only problem here, if we just wrote some code up here, whatever the code is, once you open the document and enable macro, the PowerShell window will open in front of him this black CMD window, something that looks like this, and that is something we don't really want him to see. We want to make sure that he doesn't see at all this window. So what we can do here, we can use some of the parameters of PowerShell. We have here, this is basically a Microsoft document, and this Microsoft document is giving us all the parameters that PowerShell can take. One of these parameters is window style. What's window style? Window style is basically, it's a parameter that's being given to PowerShell.exe, and it sets the window style for a session. Maybe can be set to normal, minimized, maximized, and hidden. What we really want is to make this window completely hidden, so he doesn't see it and he doesn't think that his machine is being infected. So what we can do here, we can go to our document and we can say window style hidden, so it doesn't show in front of the victim when we execute some code. So what exactly to execute? What we want to do is basically we want to get it to connect to us. We have here netcats being open on the port 4444. So we want this this document to connect back to us and probably to download something from us. We can have here netcat, we can have an HTTP backend, for example. We can use a website, we can host a website for the attacker to basically give the malware access to some documents inside, some files like malware.exe or malware.bs1, which is a PowerShell script, or whatever we want to host inside our web server, and make this document connects back to our website and downloads additional code, additional malware to execute in that machine, and gives us access, full access inside this machine. So we can use something inside PowerShell called web client, and to access this web client inside PowerShell, we need to create a new instance of that web client, kind of like opening a browser or opening a new tab or a new window. We need to use a command called new object, which creates a new instance of any service inside PowerShell. Web client, file manipulation tool, whatever the tool we want to use inside PowerShell. In our case, we'll use net.webclient, and this web client gives us access to download files, to upload files, to connect through, to send requests to websites, to receive responses, to receive files and save them on the disk. It gives us so much control. And now with this code, with this code, we were able to open a new instance of that web client. We opened a new window. So what to do with this new window? We want this new window or this new browser to connect back to us, to our IP and our port. So we took all of that between brackets. This is our browser, and now we will ask our browser to download something from our to download a malware from our web server. We can use download string. That's a command that is used to download the files from the internet. And this download string takes a URL up here, HTTP double slashes, and then our own IP, or the attacker IP, the 219, this is my IP, and then the port, which is 444. Of course, if you have a website and it's port 80, you can just skip that part, or if you have a customized port, you need to write your port up here, and then slash, and we can say whatever, malware, let's say the .bs1, if we want to execute more PowerShell code. Now, here we have downloaded a malware from our server. We have made this document to be able to download a malware from our website, from the attacker server to the victim machine just once he enabled the macro. But downloading that file is useless if we don't execute it. We want to be able to execute that code, assuming that this is .bs1 means this file is a PowerShell script. So we assume that malware.bs1 is more of PowerShell code, and we want to execute that PowerShell code inside PowerShell, inside the victim machine, and do more harm, or do more control over his machine, to have more control, to maintain resistance, to download a spyware, to do whatever we want to do. So we can take all of that downloaded PowerShell code and use the command inside PowerShell called IEX, and IEX basically executes. It's from execute, and basically it executes all the downloaded code from our website inside the victim machine. So let's recap again. We want some code to run in when the document gets open, so we choose the document object, the open event. This is the event that we want to write code for, and once we choose them, Microsoft Word has created our own wrap with private subroutine document underscore open, and at the end in subroutine, and we have to write the code in the middle. We use the command, the Visual Basic Script command called shell, which executes any code inside the shell. We use PowerShell wind style hidden to not show in front of the victim, and then execute. This is the command execute. And what to execute, basically create a new web client, a new browser, download from our from the attacker website, from our website, download malware.bs1, download this malicious PowerShell script, and this PowerShell script will be executed with IEX. So that's basically all the code we have wrote. You can modify it, you can improve it. This is just a very, very simple example. So now we will need to save this document. And to save it, if you let's close here. If we try to save this document, let's say to documents up here, and let's say we call it malware. If we choose Word documents, which is .docs, this will have a problem saving our macro code. If we click save, oh, 1 second, I think some mistake had happened. Everything is okay here. So if we open that document, it will not actually work, and it will not see any macros being running. To save it, we need to use save as, and we choose the word macro enabled document up here, and we can use the malware the same, and it will be .docm, which means it's a macro enabled document, and we click save. Now we have it malware.documents, and we can go here to the documents, and we can see our both files we have created up here, malware.com .docm and malware.docx. We can close this one. We can see each one how it will work. If we open malware.docs, we'll see just a file being opened like this. Nothing is happening. We might see some macro, but we will not see any actual code is being written up here. I'm not sure why he has two, but for this document, there's nothing is happening inside of it. There's no code is being run. But if we open that document, we can see that he's saying that macro has been disabled. You need to enable content. You need to enable the macro. And once we enable the macro, the malware will run. We will test that right now on our virtual machine. We'll close that one, copy that document, and go to our virtual machine. I hope it's not already sleepy. I will resume it. It's our virtual machine that we use to for malware analysis, and we can take this document and paste it here. And now we can execute this document. We can enable the macro and see how that will happen. By the way, for sending, if you send them a document that's .docm, that can be very suspicious. You can actually rename it to just doc, and it will run just fine without any problem. So you can rename it to .doc, but not .docx, because with X it will not be executed. Before we open the document, we make sure that our Netcat is listening, and now we double click on the document to see how it's working and how it will connect back to our Netcat. So we double click up here. It has been executed. We see the PowerShell code has been executed here, and because I have already set the macro to be always enabled, so he didn't ask me to enable macro. And we saw here the PowerShell has been running, and if we return back to here, we see we have received a request from PowerShell to connect to us. We can now send back the malware.ps1 more PowerShell code, and it will be automatically executed on the system. So that's a very simple example. Hope you like that video, and next we will move into what's after the initial access, how to maintain control, how to split privileges, how to move from one machine to other, and so on. So see you in the next part. So now we have simulated creating a spear phishing email with a malicious document, and this malicious document includes an embedded macro code that executes PowerShell and executes our own malware. This is a very, very simple way to create that. Now we want to build the next step. So now we have able to infect the victim machine and able to take control over this machine. Now we want to be able to send commands. We want to have our own CNC to send commands to move from one machine to another and take over not only one machine but the whole network. There are You can, of course, develop your own tools that help you to do that, or you can use known frameworks that are created to simulate these steps and simulate this attack. There's one called Caldera, which is an open source framework created by Meter organization. And it's kind of like your own CNC, but it is designed to run simulation exercises, to run, let's say, different commands that simulates different techniques the attacker might use, from maintaining resistance to escalate privilege to lateral movements to exfiltration and collecting lots of information, sensitive files inside the disk, inside the system, even from the file shares, and take all of that and send them back to the attacker. So it simulates lots of different techniques that you might see in the real life, and it's a really good framework to use. Another one called Cobalt Strike, and this is it's a paid app, as we said. It's very known for adversary simulation and red team operation. And this tool is more production-like. You can use it in actually real red team operation. We will now cover a simple demo on how to use Caldera. We will not cover Cobalt Strike as it's a paid app. You might see that if you're working in red team operation, you might see this tool is already there with your organization, and it works very similar to Caldera, or even easier to learn than Caldera. So now we will take a look at Caldera demo. And before that, I'll just talk about other useful frameworks. There is Empire framework, which is not longer supported. It's a post-exploitation framework that you can use to move from one machine to another, to collect information, to maintain resistance, and so on. Similar to Empire, there was Powersploit, and it's also not longer supported. There is another tool called Bloodhound, which used graph theory to reveal hidden and unintended relationships with Active Directory environment. It helps the attackers to identify complex attack paths. Basically, Bloodhound can create a graph of all the different domain controllers and users and the relationship to each other and who is inside which groups, and can help you plan your attack moving from one machine to another. So it's a very useful tool if you want to identify your lateral movement steps, or also for defenders to see what are the paths that the attacker might use to get into the organization. So now we will go into the Caldera demo, and I will see you back after. So now we'll take a look at Caldera, and Caldera can work for you as a complete CNC. In our previous demo, we had sent a malicious document to our vulnerable machine here. We're able to make it connect back to our netcat here, but we didn't have a server to receive this agent and able to interact with it and send more commands to this agent and build all of this communication. Now we'll be using Caldera to basically become our own CNC. We see all the agents that logged in to our CNC, and we can, using Caldera, we can simulate an adversaries. We can simulate from the initial access to the execution, to lateral movements, to privilege escalation, to maintaining resistance, and so on. If we go to Meter Attack Navigator here, which is this one, we can create a layer, enterprise, and now up here we can see all the different techniques, tactics, and procedures. So many different techniques we can actually simulate. We can choose to simulate, let's say, ABT 36 or ABT 39, whatever the ABT we want to, or whatever the gang and the attack that we want to simulate. We can choose we want to simulate all of these ones. Let's color them into a color that allows us to see them. So we can see here they use drive-by compromise, they used an interpreted language, which is PowerShell. They used to do to obfuscate and deobfuscate and decode files of information, modify registry, obfuscated files or information. So they used to obfuscate and deobfuscate some information they sent along the way, and files. They used to modify registry. They used to some system information discovery, network discovery, and as well user discovery. So if you want to simulate this attack, this tool can help us simulate all of these database or look at how that works. And Caldera is not only built for Red Team, it's also built for Blue Team to simulate the defense. So after an attack happens, Caldera can give the Blue Team an insight on how they can detect this attack inside the logs. Either searching through Splunk or ELK, we'll talk about them in the next module, and as well using the system logs or using different logs, they can detect these attacks. So here you can log in with Red, with Blue, or with admin. All of them, the password is the same admin. So you can log in with admin or Red and admin as a password up here, and it will show you this interface, and you can see that the whole interface looks between red and black, which includes everything related to the Red Team and to the attack. If we log out and we logged in with Blue and admin, we can see everything here is blue, and it's more about protection and detection and so on. So let's log in with Red, as we are the Red Team part in this module you are listening to right now, and let's look at how this actually works. So first, you will need to install an agent inside the system. You need to deploy your malware, and they have multiple different malwares up here we can choose from. We click here on deploy an agent, and we see here we have 4 different types of malware that we can use. One gives us the reverse shell, which is Manix, and the reverse shell is really good with it's very similar to Metasploit, works exactly like Metasploit, and we can use it to communicate with the vulnerable machine. It's a bit noisy. It uses an unknown port like 7010 or 7011, and these ports are mostly will be blocked on the back end in any company, and it doesn't look similar to any attack that we see in real life because it can easily be detected, so we can ignore that one. We can see here the Elastic Cat, and this is basically for Blue Team to execute commands on the system and query Elasticsearch so they can gather information from the logs, from different things, and able to basically understand the attack more. Another agent up here which communicates through HTTP. This is really similar to what we see in real life in the real attacks, because inside companies, inside the production network, you don't see so many ports open. If we do communicate through TCP on port 7010 or 7011 or something like that, it will be either blocked or it will be easily flagged. But HTTP communication, port 80 and port 443 are always open. The HTTP communication is always there and always allowed. So deploying a malware like this one will be very similar to what we see in real life. Up here we can choose the platform we want to target, let's say Windows, this is our case, and we can set the communication. It will be with our IP up here, as you already know, and port 8888. Of course, this port should not be for the production CNC, but that's what we can use. And here it will be the name of the malware when it's being deployed in the system, or the name of the file name. Here you will use splunkd. So it will be splunkd.exe. We can rename it to malware, we can rename it to whatever we want. Then here are the code that we can use to communicate through HTTP. And here he's saying that this code should run on PowerShell. So we can copy that code, all of it like this, close that one, and go to our VM. This is the victim that we have exploited before. We can go to SIMD, PowerShell. It'll take a bit of time, and then paste that code and click enter. Now we have infected that machine with a malware. If you read that code basically line by line, and you try to reverse it, or talk about reversing in the third module, this code basically downloads a malware on the system with the name splunkd and executes that application. We can see here we have got one agent, which is an HTTP agent, and this is basically our host desktop machine, which is the name of this machine. And now we can use that to basically execute commands and run all of our different TTPs that we want to test, all of our attacks, tactics, techniques, and procedures step by step to actually execute, to basically simulate the real EBT attack. So just a quick note here, we see we have executed that code, and now if we go to not Windows, to users public, we can see the malware has been deployed here, splunkd.exe. So, and that path is actually written, if you look inside that code, it's actually written up here, see users public, and then the name of the malware.exe. So it looks like this code is basically downloading the malware, splunkd.exe, saving it inside the user public, and execute it in a hidden window. So we have the malware running here, and we can get back to our CNC and start controlling that malware. And by the way, we can also embed this PowerShell code we used to install the agent inside the malicious document, so we can send it to the victim and take control over his machine. Now we're going to simulating the real attack. We have done the initial access, the execution. Now we can start simulating these different steps. We know how the attacker did his attack, and now we want to simulate that using our Caldera framework. We can go here to adversaries, and we can either add our own adversary, let's say EBT39, this is Cozy Bear Simulation, and we can add the abilities we want to add. We can add, let's say, execution, we can add, we want PowerShell, and in PowerShell we want to use, let's say, Mimikatz. And he will give us here the code that we can execute on the CMD, and so on. This is one thing we can use. Or we can actually view we already have inside the Caldera some already predefined adversaries we can use. We can use the check, for example, which already includes a list of abilities to collect information about the victim. We can use that directly. We can say here it gets the current user, the working directory, the list of directories, the processes are running in the system, and so many different information. So this one, for example, the check, collects different information about the machine and sends them back to us. Another one we can use is the thief, which basically it searches for specific files with specific extension and collect these files, zip them, and send them back to us. So it goes to the victim machine, search through all files with specific extensions, just collect them, zip them, and send them back to us. There's multiple different adversaries up here. One thing to add here, we need to be sure that each one of these abilities is actually executable in our agent. our agent is basically Windows and it is PowerShell. So we need to make sure that each one of these is Windows and PowerShell. We see here it works on Mac, it works on Linux, it works on Windows PowerShell and another PowerShell core. And we see that in different things. If we go to check, for example, we see that they are always executed on PowerShell or CMD. So we need to be sure which one we are choosing for our system here. Is it working on PowerShell or not? Is it working on CMD or not? And we see here, this is, for example, working on Windows command line. So now we know how advisors work and how their profile work. We know how to add one if we want to add customized abilities or use one of the already predefined advisors up here. Then we need to go to operation to start actually creating that attack. So how we do it? We check this to add, and then we add a name, let's say demo, and here we choose red, let's say, because this is the group that we are working on right now. We are on the red team, and we choose one of the advisors, either the customized one we have created or the predefined one. We can choose here, let's say, the thief, for example. And we can say keep it open forever or auto close, run immediately or pause on the start, and then we click start. Once we click start here, we can see that we started to execute different commands. You can see one by one he is executing. The first one is creating a staged directory, and this is basically the command he sent to our PowerShell agent. And he created a new directory called staged, and then he tried to compress it, but there is no file, basically because there's no files was included inside staged.zip, so it wasn't compressed. This is just one example. We can add additional commands by ourselves. We can choose our own agent, and we can run something like dir, for example, as a simple command. I think I have an agent with an error. Here's one command up here. We can also add potential links. We can choose this one, and it will give us all the different PowerShell commands we can execute on that system. There is 282 different PowerShell commands we can execute that does something inside that system, whatever bypassing the user access control, whatever doing lateral movement, collecting information, and so on. We see here user access control bypass. We see here invoke some HTML application to simulate lateral movement, add a domain to a trusted zone. We say so many different things up here. Here, a prompt user for a password, for example. We can add this one. We can add so many different things from here. Whatever we want to simulate, we can add here. And we see that the first command we sent has been received and give us all the different directories that we with dir command, which basically shows us all the different files and directories inside the current directory. And we see our current directory is cuser, and this is all the files included there. If we have sent our prompt user for a password, and this is basically the command. And we can go here, we see if there's any password have been asked for. Doesn't look like it has been executed correctly. We need to always test all of these commands because Caldera doesn't have all the commands work perfectly fine. So we need to test them, we need to improve them. We need as well to improve the ways, improve the look of these commands because it can easily be catched by the by antivirus programs or even Microsoft partial protection. So we need to make sure that we obfuscate them. They have different obfuscations up here, and we can have our own manual obfuscation. We can add manual commands that actually simulate different things in the emitter attack up here. We want, let's say, to simulate Bit's job that's not included inside Caldera. We can run a command by ourselves to do exactly that, and so on. We can say, okay, we'll delete this one, and we will create a new operation that does check, for example, and click start. And this one, it will ask for the current user, list directories, do different things, and we can wait until it finishes. It takes a bit of time. And then we can see what is the name of the user, what are the list of users are there. We can see here, he returned back the username, which is user, which is correct. Now he will start to send the next command and the next. Now print the working directory, and we can see all of them are, all of the different commands will be sent step by step in front of us. We can even change that from autonomous to manual, which asks us for approval on every single command we want to send. So we can say we don't want this command, we want another command. Also, looking at these circles, we can see which one has been successful, which one are queued. So this one is being queued. The list of directories, he is asking us, do we want to approve that command or not? Because we changed it to manual. So we say we approve. And we see the previous one that was queued, now it is successful. And we can see now he gives us exactly the path that we are already in. And now he's sending the list of directories. We can change it back to autonomous if we want to just run all the commands after each other. If there's a red circle represents a failure, a blue circle represents timeout, and so on. We can even discard some of these commands, like here, for example, to basically cancel this command. It has been actually executed fine, so we didn't cancel it on time. And he will keep sending all the different things we saw in the check. Here's view process. We see all the processes been running on that system, all the applications that are running, and so on. So with that, we can collect all the information about the attack, about the victim, and we can create our own adversary from these different pre-defined adversaries. We can add the abilities we want to test. We can add manual commands to test different things inside the attack navigator, or escalate privileges, maintain persistence, or access, or dump or run Mimikatz and collect credentials, do lateral movements, and so on. This is basically this app. Caldera is not the best app you can see in the market. There's better apps like Cobalt Strike, which is very, very known. It's premium, it's paid, but it can do a better job than Caldera. But Caldera is free and it's very modular. It's open source. You can easily modify it. You can create your own agent, create your own abilities, and as well create your own adversaries and plugins and so on. We see here the IP config, and it shows us the IPs and the net mask. One of the good things to mention about Caldera, that it's really good in catching and collecting information and parsing them. So now he add this information as a fact in his own library, the IP and the mask. Now we can use this information later in other different abilities later on, which is something we can really use inside Caldera and have a database of the whole information we collected through the attack. So that's it for that video, and see you in the next part. We have covered a lot in that session, and now I know that wherever how much we stay, it will not be enough to cover all the reteaming and all the penetration testing. And for people who think that I'm attacking the penetration testing, the traditional penetration testing, it is very important information. It is the foundation. But if you want to be more unique in the market, you need to learn the red team operation. You need to learn how to protect the company from the attacks that's happening nowadays, not just perform a traditional penetration testing. I have also heard a lot that people who go through normal certificates or non-certificates, there are so many people in the market who have very known certificates without mentioning names, and they know nothing about penetration testing. They know nothing about performing these attacks. So it's very, very important for you to build the practical skills. There's one a friend of mine here who was saying always, it's called Muhammad Kharisha, he was saying, be qualified, then certified. Certification can help you get in the front door into the interview, but it doesn't help you to prove yourself. As well as its certification is something that so many people might have the exact same certificate like you. It's something that doesn't make you unique. So you need to have things that prove that you are unique. That could be creating your own blog, creating your own reports, and learn the things that companies are talking about nowadays, the attacks that they talk about, the vulnerabilities they talk about, the type of attacks that mostly target them, and how to either simulate these attacks or defend against them. Some additional resources to use, a book called Advanced Penetration Testing. It's a really good book and has lots of different stories on how they perform their penetration testing attacks. It's not a simple book, but it has so much about, it's not really beginner friendly, but it has so many different things to learn about EBT simulation, about real attacks and how they look like. So I recommend you to check that book as well. Check MetaAttack references. They have all the techniques you have seen. There's over 140 techniques or more. All of these techniques, they have a description about them, what exactly this technique look like. They have how to perform them, how to defend against them. So it's really a good library for you. As well as look at Caldera plugins. Caldera, they have so many different commands to execute so many of these techniques that you saw in MetaAttack. Look at them, learn these techniques, learn this PowerShell code, help them create your own library of commands to simulate different attacks and different techniques, to be able to escalate privileges, to take over the machine, to move from one machine to another, doing lateral movement, all of these different things, and build your own arsenal of techniques, of commands that you can use in any different situation. Your own defense evasion library, how you can bypass Sysmon, how you can bypass PowerShell logs, and so on. So I will leave you now with this. Hope that module was helpful. I know that was not everything in penetration testing, but I hope it's a good start for you. Learn all the things that are in traditional pen testing and add to them the practical exercises, your own blog, to show that you have been learning through the whole time and you're learning different things. And the third and most important thing, focus on reteaming. Focus on the attacks that actually target the organization. Nowadays, focus on the attacks that has the value, because your value is equal to the value of the attacks you can simulate or you can protect the company against. If these attacks cost the company millions of dollars, then if you can simulate these attacks or you can defend against these attacks, you are worth this $1 million they are losing. So make sure that you learn the real attacks that's happening nowadays. Also, one resource I forgot to mention, look at the EBT notes. There's in GitHub a repository called EBT notes, which has so many different articles about different attacks have been performed in real life. articles from Symantec, from Kaspersky, from FireEye, from ESET, talking about real attacks, how they have been performed, who are their victims, and how the attackers craft their attacks step by step. They also explain their own hacking tools or own malware, how their malware look like, what exactly the command is being received, how for an organization, how they can protect themselves against this attack. Make sure that you read a lot of these articles and learn from them. See how these real attacks look like, how you can simulate them, how you can copy from these attacks and build your own library of PowerShell commands, of shell commands, or whatever your own library of techniques and your own library of commands that you can use when performing penetration testing. So hope that was helpful, and see you tomorrow in the next module.